Alright everybody, today we are starting 3-5, which is determining the number of solutions that an equation has. And there's going to be three answers. It doesn't matter what the actual numbers are when you solve, we just want to know three different things. Is there one solution? Is there no solution? Or is there an infinite number of solutions? So there's only going to be two examples today, and we'll go through the little chart at the bottom. But that's all this is. So our goal for their learning intention, I am learning to determine how many solutions an equation has by simplifying both sides. We're not even really solving for x. We are just simplifying each side. Okay? Hopefully by the end of this class, you can simplify both sides of the equation. That's what we've been working on for a while now. I can compare the expressions to see if they're equal or not. So we're literally just seeing, does the left side equal the right side? Is it different? What's going on? And then I can determine if an equation has one solution, no solution, or infinitely many. That is the main goal of today. Can you do this last one? I can determine if an equation has one, no, or infinite many solutions. So we're going to look at this. It kind of tells you the answer right here. Equations with infinitely many. What we're going to do is we're going to solve 6 times x minus 3 plus 10 equals 2 times 3x minus 4 and determine whether the equation has one, no, or infinitely many solutions. We're going to use similar steps that we've done in the past. All right? So we have our equation. We're going to use the distributive property. So we're going to multiply 6 times x and negative 3. We're going to multiply 2 times 3x and negative 4. So 6 times x is 6x. 6 times negative 3 is negative 18. Plus 10 equals 2 times 3x is 6x. 2 times negative 4, that's negative 8. Combine like terms. Again, we still have to go through that. On the right side, we have an x term. We have a number. We can't combine those. On the right side, we have 6x minus 18 plus 10. We can combine these two. Okay. So we have 6x. What's negative 18 plus 10? Well, that's minus 8 equals 6. Well, isn't that interesting? We have the same thing on both sides. Well, we got to keep going. We want to have, we still want our x's on one side, still want our numbers on the other. So we're going to, there's nothing that's smaller, so it doesn't really matter which one we do. So we're going to subtract 6x, subtract 6x. That's all they're telling us to do right now. That's all we have to do. When we do that, both sides cancel. So we're left with negative 8 equals negative 8. That's fine. Is that a true statement? So this is the first type of problem that we're going to see. When both sides are equal, there are infinitely many solutions. That means no matter what number you plug in for x, it's still going to be equal. You can plug in a 1, you can plug in a 2, you can plug in a 67, you can plug in a 42, you can plug in a 1738, whatever you want to plug in, you can plug it in. Infinitely many solutions because both sides were equal. Let's look at another one. Again, solve this equation. We're going to do it the exact same way. We're going to distribute first. Distribute first. 8 times 4, 32. 8 times negative 2x. That's minus 16x. Equals 4 times 3, 12. 4 times negative 5x, negative 20x, plus 4x. Now we got to combine like terms. That left side, we have a term. Oops, I am down here. Sorry, you couldn't see much of that. So again, we're here. We distributed. Distributed, 8 times 4, 32. 8 times negative 2x, negative 16x. 4 times 3 is 12. 4 times negative 5x is negative 20x. And we didn't do anything with that plus 4x, so we just brought it down. We got nothing on that left side that we can combine. But on the right side, we have negative 20x plus 4x. Combine those. We didn't do anything with the 32 minus 16x. We didn't do anything with the 12. What is negative 20x plus 4x? Negative 20x plus 4x, that's negative 16x. So same thing, we're going to get our x's together. Doesn't matter which way you go because they're both negative 16. So I'm going to add 16x to both sides. They cancel in both spots. Now I've got 32 is equal to 12. Well, does that make sense? Absolutely not. So, because it doesn't make sense when both sides are not equal, there are no solutions. Right? And that's kind of what it says down here in math terms down here. So again, symbolically, a number equals a different number. Or something like 4 equals 0. We had 32 equals 12. When the numbers don't make sense, when they don't equal each other, there's no solution. When you go through and you solve and you get x equals a number, we didn't see one of those here. We've seen plenty of those when, like we have here 2x equals 20, you divide by 2 on each side, you get x equals 10. When you get x equals a number, that just means that that's the only solution. There's one solution. Okay? So when you still have an x, in both of these, we completely got rid of the x's. We haven't seen anything like that. That's why these are the two types of examples that we saw. We've seen plenty of these. This is what we've been doing. You did these last year in 7th grade. You're doing it now when we're solving multi-step equations. We always end up with x equals a number. Okay? So that's when there's one solution. Infinite, like we had up here on top, that's when you have a number that equals itself. So in this case, they said 2 and 2. Up here, we had negative 8 and negative 8. When they equal each other, every value of x is a solution. So when you're solving this, when you're going through, if your numbers equal each other, if your side, we could have stopped right here when it was 6x minus 8 equals 6x minus 8. We see that it's the exact same thing on each side. That's infinitely many. Once we get down here, when we have no more variables, we've gotten rid of them, but our stuff is not the same, that's when there's no solutions. If you still have an x in your problem, there's going to be one solution. Quick notes today. Go ahead and work on that next page of assignments. If you have questions, please make sure you're asking.